Please welcome Google's Vice President and Engineering Fellow, Partha Ranganathan.
Hi, everyone. It's a pleasure to be here. It's good to see everybody in person. So much energy, and I see standing room only here, so really nice. So my talk is titled Sustainable, Secure Societal Infrastructure for the AI-Driven Era. And I'm going to structure my talk in 3 parts. I'm going to start off with talking about some of the opportunities we have ahead of us in terms of AI. I will present 3 minutes, security, sustainability, and scalability, and I'll talk about how we as a community can get together. And then I'll end with the call for action. OK, so I don't think anybody's going to be surprised when I say that we are at a once-in-a-generation inflection point in computing. All the prior keynotes have talked about how we are at a very interesting point in terms of AI. But let's jump a little bit deeper into that. In prior talks, when I've given keynotes at Google, I've talked about how at Google, we work on the planet-scale computing that underlies all the services that power billions of users. And as part of doing that, we have solved some phenomenal challenges around how do we get high performance, how do we get efficiency, resiliency at hyperscale. But this talk, I'm going to focus on something different, AI. Now, our products have always had AI inside them. But what we have seen in the past year or so is a bunch of fundamental tectonic shifts, large language models, generative AI, that have supercharged all these projects. One of my very favorite examples is how generative AI is transforming productivity. If you look at last year alone, in Google Workspace, we had AI-driven writing and related optimizations used about 180 billion times. But it's not just the consumer part. If you look at enterprises, across different enterprises, whether it's technology, telco, media, retail, healthcare, finance, manufacturing, over and over again, we are seeing AI being used in a multitude of ways to be able to take complex data and make it intuitively accessible, to start providing more interactive natural language interactions for online interactions, and also start thinking about more creative content generation. And it's not just business alone. Generative AI has the potential to fundamentally alter everything that you can think about, whether it's health, creativity, entertainment, business, productivity, and so on. And of course, we have to do all of this while being very cognizant of our responsibility and ethics here. We need to think about safety, privacy, security, and so on. And so when you think about all of these advances in AI that we just talked about, they also have implications on our assumptions around the models and infrastructure that drives computing. In particular, this animation here shows the journey that we have taken at Google, starting all the way from the original Transformer paper that underlies all the advances we see today, to most recently what we announced at Google I/O, whether it's BARD or PaLM or the other models that we are working on. And one of the really interesting observations here is that we started off with models that had literally hundreds of millions of parameters, and we have evolved to models that are starting to be around trillions of parameters. That's about a factor of 2 every 3 months in the model size. And with great model size comes great compute. And so this picture on the right here shows how the need for computation has also been increasing at phenomenal exponential rates. And so really the takeaway here is that AI is not only a powerful enabler, but it's also a fundamental platform shift. And we as a community, we need to innovate across hardware and software to think about how we are going to provide the infrastructure that drives this AI-driven future. So this leads us to a bunch of very fundamental questions that we need to answer. How do we design scalable hardware and software platforms to provide these ML supercomputers that drive AI? How do we deliver these systems with incredibly high amounts of reliability, safety, availability? And third, how do we optimize for these systems, delivering these at extremely high levels of efficiency, the greenest possible system across all of these broad industry ecosystems? In short, how do we design sustainable, secure, societal infrastructure for the AI-driven future? So I'm going to talk about each of these very briefly. So let's start with sustainability first. Now, when we think about sustainability, we all realize it's an absolutely important imperative that we care about. Google in particular is really passionate about this space. We have made some very audacious goals, whether it is 24/7 carbon-free energy by 2030, or whether we talk about net zero carbon, not just across our operations, but also across our value chain by 2030. And so how do we kind of, as an industry, get together to address some of these audacious goals? So today, I'm very, very happy to announce the Net Zero Innovation Hub for data centers. And interestingly enough, this started off as a proposal in OCP's Regional Compute Summit earlier last year. And we've been just blown away by the response that we got for that call. And so together with Microsoft, another Open Compute member, and Danfoss and Schneider Electric, we are very, very pleased to have the first pan-European public and private collaboration to address sustainability at a regional level. And we think this model has the potential to expand to other regions and geographies as well. And I'm very pleased, again, at the momentum that we already have with the Innovation Hub. We already have a lot of really good conversations, and we are also starting to see some specific work streams emerging around waste heat and grid availability and so on. I also want to highlight two other very interesting contributions in recent times. The first one is around greener concrete. Across all the hyperscalers, Amazon, Microsoft, Meta, and of course Google, we got together and we put out a very ambitious industry roadmap to decarbonize concrete in the data center. Now, concrete in the data center as a fraction of the total carbon footprint in the world is not significant, but concrete across all industries is more than about 10% of the total carbon footprint. And so our hope is that this community, our industry together, we can set the standards for some very ambitious goals in concrete that elevate the entire industry together, entire world together in terms of some of our concrete stuff. And so I'm very excited about that. The second thing we want to talk about here is what Google has been doing with others on the DCF sustainability workstream. And in fact, I think we are addressing what is probably the most fundamental problem in sustainability, namely the availability of clear, consistent, standardized metrics. And these are not just metrics for emissions and carbon, but also energy, water, circularity, ecosystem as well. So that was sustainability. So now around security, I want to talk a little bit not just about security in terms of confidential computing, but more broadly in terms of reliable computing as well. And so the first thing I want to talk about is our contributions around Calyptra. So how many people here have heard of Calyptra before? Okay, a good chunk. So we announced Calyptra last year along with our founding partners, Microsoft, AMD, and NVIDIA. And today we are very happy that compared to the draft spec that we had, we now have IP ready for root of trust in CPUs, but also in GPUs and all possible SoCs. And our membership has expanded to a large number of companies as well. Similarly, I'm very excited that today we announced OCP SAFE. SAFE stands for Security Appraisal Framework and Enablement. And what we have done is we have taken a lot of the best practices that we have at Google and other OCP member companies, and we have provided a standardized approach to look at everything across the server lifecycle, provenance, code quality, supply software chain, and look at multi-vendor agnosticity in terms of how we do that. In reliable computing, I've talked in the past about the problems with silent data corruption, and so I'm very happy that we now have open SDC frameworks. But we've also been thinking in terms of specifications and standards around server component resilience and testing that we have contributed as well. And finally, I'm very, very happy that for the first time in Open Compute, we now have this new OCP academic program where Google and other members, we have 4 other members now and more joining, we have gotten together to produce an academic corpus where we can encourage future innovation, future research on this very, very important problem. So I'm very, very excited to see how this experiment goes. The third part is around scalability, and this is something, again, that we do really well at Open Compute. And scalability is not just across compute, but it's across compute, storage, networking, all the way from silicon to cloud. And here I really want to call out a whole bunch of contributions that we have been making around infrastructure for AI ML. So it starts off with everything from the base silicon accelerators, things like chip-level specifications for 8-bit floating point. But we've also been looking at RAS specifications for firmware and how do we build accelerator systems. And then my all-time favorite, how do we think about OpenXLA or compiler infrastructure to encourage the innovation that we want to see across hardware and software. Again, in the spirit of the industry-academia collaboration that I talked about earlier, we also have an announcement around Architecture 2.0. And this particular effort is really interesting to me because beyond just the traces and the data sets and the tools and infrastructure that we are looking at, we are also thinking about going beyond just systems for AI to thinking about AI for systems. And I'm very excited to see where that goes as well. And then on networking, today, Google announced that we are opening up Falcon. So Falcon is our very reliable, low latency, high performance hardware transport protocol, which has decades of Google innovations in this space. And we are opening this up to Open Compute and all the Open Compute members. And we see this as part of the broader efforts to advance Ethernet as a high performance networking fabric, both for hyperscale and for AI ML workloads. And you heard Ram talk about this a little bit earlier as well. And then on storage, we continue to make a whole bunch of contributions, particularly around NVMe for fault tolerance. So we are looking at key management, but we are also looking at flexible data placement and various aspects with NVMe as well. So that was kind of a quick whirlwind tour of the various contributions we've been making around some of the most fundamental challenges, sustainability, security, scalability, as we think about the AI-driven era. But really, this new era of AI systems is going to be underpinned by a healthy, open industry ecosystem. And so Google, of course, we love open source, whether it is something like Kubernetes or TensorFlow or JAX or Chrome or Kaggle. We've always kind of believed in the value of not just open standards, but also building healthy ecosystems and being able to share best practices. This summit is a great example of something like that. And our partnership with Open Compute has gone for multiple years, all the way starting from when we first contributed our 48-volt power supplies to today, where we are engaged in a whole bunch of activities, including Amber Huffman, who's on the board of directors, and we are engaged in all the work streams there. And in this summit alone, we have more than 30 different talks from Google. So I'd encourage you to go there and really cheer everyone up as well. Lots of really nice contributions there. So all of this open industry ecosystem cannot be possible unless you have a healthy spirit of collaboration and co-design. And so that is kind of my call to action here. And hopefully you've seen this in the talk throughout. It is not just collaboration across multiple companies in Open Compute. It is collaboration and co-design across hardware and software. It is co-design across compute, network, storage, and infrastructure. It is collaboration across industry and academia. It is collaboration with startups. And so I want to leave with that as my last concluding point. It is not often that we as a community get to be on the ground floor of a step change in computing, a fundamental, pivotal, tectonic shift in computing. We are at that moment today. The AI-driven era is going to fundamentally alter how we think of computing, and it's going to fundamentally alter how we think about designing hardware and software systems for this new era of computing. And so this innovation, whether it's around security, sustainability, scalability, is really going to build the fundamental societal infrastructure for the future. And we can only do all of that together. And so hopefully, as you're listening to all the other talks in the summit in the next 2 days, I'd invite you all to join Google and Open Compute. And I'm really looking forward to seeing what other advances come up in the future. So thank you for your time.